Okay, let's look at 2008 AP Calculus Free Response question. This is Form B, number 1. You are allowed a calculator. It's an older question, fairly straightforward area volume question. They give you a relatively easy to graph region. Graphing is not mandatory, but it certainly helps with the visualization. We have y equals square root of x, which I'm going to do this really quickly. Square root of x is going to look something like that. And x over 3 will be aligned with slope 1/3 through the origin, and they will contain that little region right there. And a little bit of simple algebra will show you that x and the square root of x and x over 3 will intersect when x is equal to 9 and when y is equal to 3. So we're at the ordered pair 9, 3 right there. And the area would be a straightforward top minus bottom situation. So antiderivative of the top curve, square root of x, minus the bottom line, x over 3. Do put the dx. They don't always count off if you don't put it there, but it's supposed to be there. This is a dx problem, so we're starting this area from 0, marching our way up to 9. 0 to 9, and there is your setup. And while you have the ability to do this antiderivative without a calculator on the AP Calculus exam, if you are allowed a calculator, then punch this in the calculator to get your answer. You get no extra points for showing your integration skills. You get to do that on the non-calculator portion. So I'm going to throw this in a calculator real quick to get the answer. And I got 9/2, or 4.5 would be fine if you want to go decimals. And there's your answer to A. So question B asks you to find the volume when you rotate that region around the vertical line x equals -1. And so my axis of rotation is over here at -1. So here's my axis of rotation, is a vertical line. My region is over here, looks something like this. And I'm very quick, wow, that was bad. Very quickly drawing this in here again. And this, when I do these volumes, I always ask the same questions. I'm going to do this with a cross section. My cross section is a washer. Then I choose the variable, and when you do your washer, we're ultimately going to need the area of that washer. The variable is determined by the axis your measurements are perpendicular to. So my axis of rotation is over here to measure the big radius. We're going to go from the axis of rotation to the far boundary, and my little radius is going to go from axis of rotation to the near boundary. So there's going to be my little radius. So my big R right here, both of these radii are perpendicular to the y-axis. That makes this a dy problem, which means all equations have to be in terms of y. So if y is equal to the square root of x, x is equal to y squared. If y is equal to x over 3, then x is equal to 3y. You have to have your equations in terms of y. And in this case, my big radius, when I measure that, that's going to be from right point to left point. So we do the right point, which is on the line 3y. My left point is on the line x equals -1, so I do right minus left. Big radius is 3y plus 1. Little radius, again, I'm going to do right minus left. My right point of the little radius is on the curve, x equals y squared. My left point is on the vertical line, -1. So when I do right minus left, I get y squared plus 1. And now I'm ready to put this into an antiderivative. So it's pi, antiderivative of big R squared, so 3y plus 1 squared, minus my little r squared, y squared plus 1 squared. And then my limits of integration, because it is a dy problem, I have to do the y coordinates of the limits of the intersection, or of the boundaries. So my intersection here is 9, 3. I'm starting down here at the origin. So we're going to go from 0 up to the upper boundary, which is at a y coordinate of 3. And again, this is a non-calculator problem, so just throw this in the calculator, get an answer. While you should be able to do this by hand, it will take a lot of algebra. You'd have to expand all of that. It will become a power rule. You can do it, but don't. Just throw it in a calculator. And when you throw that in a calculator, you will get the answer of 130.0619, which would allow you to truncate at 130.061 or round up to 130.062. This is also, if you want the exact answer, 207 pi over over 5. And depending on your calculator, some calculators will give you that answer, some calculators will go straight to the decimal approximation. And then that brings us to question C. And question C is the known cross-section volume. And so again, my region looks something like this. We have y equals square root of x up here. We have x equals, or y equals x over 3 right here. And my cross-sections this time, and I prefer these questions, I love these known cross-sections questions because they tell you two key pieces of information. First, we're cutting perpendicular to the y-axis, which automatically tells you it's a dy problem. And then they tell you the shape that we're dealing with. It's a square, because when I'm accumulating the volume through cross-sections, you're basically doing the antiderivative of the area of a cross-section. So we'll ultimately do the antiderivative of side length squared. All I have to do now is get my side length in terms of y, and my side lengths are in this region perpendicular to the y-axis. So there's my side length right there, the distance across that region. So there's side length, and this side length again is going from right to left. It's dy, so we're back to our functions in terms of y. And my side length will be my right point, 3y, minus my left point, y squared, and that is what we're going to integrate. So we're going to do the antiderivative of that whole side length, 3y minus y squared squared, dy. And my limits of integration again will be from 0 to 3, because 3 is the y coordinate that is the upper part of this boundary, of this region. So 0 to 3, there is your antiderivative. And once again, we will just throw this in the calculator, and this gives us a nice clean answer of 8.1, or if your calculator gives you the answer as a fraction, it is 81 over 10. And for this problem, they do stress on the AP exam to give all answers accurate to the third decimal. You don't have to put 100, because 8.1 is the exact answer. Just because you're supposed to be accurate to the third decimal doesn't mean you have to do this. Not wrong if you put the 2 zeros there, but not necessary either. And there are the answers. As far as grading breakdown, here is how this one was graded. For question A, you got 1 point for getting the limits of integration correct. You got 1 point for getting the integrand correct. And you got 1 point for getting the correct answer. Notice there is no point for finding the antiderivative because it's a calculator question. They expect you to set it up and then put it in the calculator. You could have done this as a dy, which honestly would have been a little bit easier. You don't have that fraction exponent. However, since you're using a calculator and not doing the antiderivative by hand, it really doesn't make it a whole lot easier. It does look a little bit cleaner, but that is an acceptable setup also. For B and C, your functions must be in terms of y. If you look at B, it is 4 points total. 1 point for the constant and limits, right there is 1 point. 2 points for having the integrand set up correctly, and then 1 point for getting the answer in any one of these forms. And again, there's what I was saying earlier, you can truncate at 0.061 or round up to 0.062. And then question C, part C, you got 1 point for the integrand and 1 point for both the limits and the answer. So the limits and the answer combined to a single point. And there is your grading breakdown for this question.